Hi, this is Professor Stugard, and in this video we are doing our lab on the data set called Jobs in Data. So, I have RStudio open. I have uploaded the two files, the Markdown file and my CSV file. Again, the first couple of things I want to do, let's title this project so we can find it later. I'm going to call this Jobs in Data. I know that I need to install Tidyverse, so again, I'm going to do that in my console first since that's going to take a while. I can open up my Markdown file. Again, Jobs in Data, author, you're obviously going to have to change that. We have it as the system date, so that's good too. And I will knit this in just a second. But again, what we're doing here, let's see, did we finish? Still working. Is we're going to look at this data set, Jobs in Data, which I got from Kaggle, who's a person who basically scraped the web for a bunch of different job postings about jobs in different fields of data science and put it all together for us. All right. And now that Tidyverse is installed, perfect. We will do that. All right. So the first things are preliminaries. We are going to install the packages, upload the data. Let's see. So that means install Tidyverse. We'll put that in our Markdown file. The library Tidyverse. We'll put that in our Markdown file. And then our data. So again, we can, I guess we can call this data frame maybe the jobs_df for data frame. We're going to store that in our environment now by using the read CSV function as usual. So read CSV, then the quotes, and this is our jobs in data.csv. Good. Okay, so perfect. We have our jobs data frame here. We can see that we have some characters, some doubles. All right, let's make sure that we copy and paste and put that code in there too. So that's in our Markdown file. So again, we have our packages, which is just Tidyverse this time, and our one CSV for jobs in data. All right, so then the next thing is, as usual, we want to explore the variables. And so I kind of already mentioned that there's definitely some questions about what these variables mean, so let's do two things. As usual, let's just look at the head of our jobs data frame, see what it looks like. So, looks like we have work year, so when that was posted, so we got 2023. We have job title, like a data architect or a data development operations engineer, which is in, these each have their own category here. Again, we have data scientists, data architects. We have whether the salary is given in euros or US dollars, the salary in US, so it looks like they converted that for us. Looks like there's more variables too. So again, it looks like every operation is a job post, every observation is a job post. Let's take a look at all those variables. So let's glimpse now my job data frame. And so let's see. So again, we had the work year, which is stored as a double, so those are all numbers. Our job title, which are stored as character strings. Job categories, also character strings. Salary currency, which is character strings. All right, so not a big problem if these are stored as character strings. They could be stored as factors if we have different levels here, but that's fine. The salary, again, the currency, then the salary, what the salary would be converted to US dollars, where the job is, looks like we have Germany, United States, so on. The experience level, mid-level, senior, employment type, full-time, work setting, hybrid, in-person, probably remote, then where's the company located, and then the company size. And again, looks like that would be the characters, looks like L and M, so I'm guessing large and medium. So we have these 12 different variables. We have to figure out which ones are going to be useful for what we're looking at. So first of all, we probably don't need work year. We're going to take a look at all the postings again. But if we want, we could definitely try to figure out If we have really old jobs, maybe that's not so useful. So again, we can always, since that one is stored as a double, I can look for the minimum using my min. And then if I want to see what the minimum of this column is, what the minimum of this variable is across here, again, we're going to have the data frame jobs df, so jobs underscore df. And then to get to individual columns, we use the $sign. And again, we kind of see that the $sign's there as well. The $sign, and then work underscore year. Why isn't my jobs data frame? Oh, because I called it job, not jobs. There you go. All right, I'm probably going to make that mistake a lot. So I think I'm going to switch this up. I'm going to call this the jobs data frame. And in fact, I'm going to go all the way back. I'm going to call this the jobs data frame. And then, yeah, I think that will hopefully make life a little bit easier for me. I think that means let's get rid of the one that is incorrect. So again, I'm going to leave the jobs. I don't want just job. So I'm going to remove, we can use the remove or RM, and I want to remove the job data frame. Let's get rid of that. Good. So now that's gone. And again, that's just a really useful feature. Anytime either we title something incorrectly, we want to remove the incorrectly titled thing, or sometimes we go through and we do a bunch of work and we have all these different things that we stored in our environment, kind of intermediate variables or something like that, and we want to just clean it up. We can use the RM or the remove to get rid of that. But again, just make sure you change the code up in the markdown, and then everything else here as well. So, okay, let's try that again. So the minimum of my jobs data frame, df, so again, we can let it autocomplete. Probably would have helped there as well. Then tab and work year. So 2020 looks like the oldest job posting. So I think that's fine. I don't think we have to worry too much about looking at jobs that are super duper old. This is only going to go back to 2020. All right, so then we probably don't have to worry about the work year here or do any filters there. We also have the variables for job title and job category. So what's the difference between a job title and a job category? Well, what we might want to do here is try to figure out how many different options we have. These are stored as characters, not factors. If it was factors, it'd be nice because then we would have levels and we'd know exactly how many levels. But in this case, I don't know how many different job titles there are or how many different job categories there are in this data frame just yet. And the way I can figure that out, there's different ways, but I'm going to use the unique function. So unique, UINQUE. And similarly, I want to figure out how many unique entries there are in that particular column in my data frame. So we'll start with the jobs data frame, then the $sign to get to our column. And I'm concerned about, we're going to look at the job title versus job category first. So job title. All right. It looks like, so again, it made the list. It looks like there's 125 different unique job titles. So we can scroll through all of them. This is actually kind of the nice part here, my console. So again, from the data development operations engineer, data architect, data scientist. And again, it looks like we have lots of different job titles, up to 125. All right, what about the unique number? So again, we'll go for my jobs data frame, then the $sign, and then the jobs category. All right, so category, looks like it's displaying this a little weird, but that's okay. It looks like there's 10 different job categories because they're putting 2 on each row. So we have data engineering, and data architecture and modeling would be 2 separate job categories. So it looks like there's 10. That looks like that's a much more reasonable way for us to look at the data. So I think job category is going to be a better way for us to categorize these jobs. And again, that's one of these things I have in the Explore Data section. There's variables for job title and job category. Which one's going to be more useful to explore? And I believe it's going to be the job category. So I want you to explain in words. I want you to type your answer here in your markdown file about how we determined that the job category is probably going to be more useful for our purposes. All right. Now, the next step. And again, you don't have to necessarily include any code here for this part. This is all just exploring the data in the console, but explain what we did in the console in our markdown file. Now, this next thing, we want to use contingency tables, which means we want to find out which of these we're looking at job categories because that's more useful. And then let's also look at the experience level. Let's pick that as my next variable that I want to look at. So again, we see that we had all these different categories. Salary, we'll obviously be looking at salary and probably salary in US dollars to kind of normalize everything. Employee residence, well, yeah, maybe at some point we'll focus on where these jobs are located. But I think experience level is going to be important. Are we looking for entry-level positions or senior-level positions? Employment type, we can see if that's interesting or not. The work setting, again, hybrid in person, maybe that's interesting or not. And then company location, we'll probably look at United States, right? Again, if we have a remote job, you could live in the United States and work in Germany, I suppose. And I'm not too concerned about the company size here. So again, I think the job category and the experience level will be the first ones that I really want to look at. Now, if we notice, actually I'll go back, those two variables are two categorical or two qualitative variables. I mean, we can see that the shortest characters, but obviously each of those categories is its own category. That's what makes it a categorical variable. It's not a number, right? It's not a numerical variable. It's not a quantitative variable. We have a qualitative or categorical variable. And then the same thing with the experience level. Again, that is categorical. That's not a number. And so if I want to compare or try to investigate the relationships between categorical variables, well, I can't use correlation coefficients because those require numbers. That's for our numerical comparisons. So usually the best way to do it is with a table of some kind. So we can use contingency tables or two-way tables. Those are kind of interchangeable, which again, we can look at two categorical variables at the same time and try to see if there's any types of patterns here. All right, so to make a table in R is, well, fairly straightforward. It's the table function. And so just be careful. There are base tables that are stored in different ways, kind of part of the tidy R package so that you can play around with data sets. And again, we've obviously done that before, like the Palmer's Penguin. When we loaded that package, it came with its own data sets. So again, just be careful. We want the form or the function for table. And now I want to tell R what to make the table out of. What are my two qualitative variables that I want to use? And so, well, we're going to pull from those two columns in my data frame. So jobs, data frame, and then again, we're going to use the dollar sign here. We're going to go down to, we'll do job category first, comma, and then jobs, data frame, dollar sign, experience level. All right, we'll run that code, and we can see this makes a two-way table for us where it lists all of the, again, our rows will be the first one we pick. So the job category becomes our set of rows. So we can see that there's job categories in BI, which is business intelligence and visualization. Then we have cloud and database, data analysis, data architecture, data engineering, data management, data quality, data science, leadership, and then machine learning and AI. So again, those are our 10 categories. And our job level, entry level, executive, mid-level, and senior. So what's nice about this table is, again, we can see that all these numbers are basically the overlap. How many of these jobs fall into each overlapping category? So for example, if we're looking at, say, data analysis, out of the data analysis, there are 140 entry-level jobs, 16 executive, 397 mid-level, and then 904 senior-level positions that had job postings. So again, this table is really useful. We can see where everything lies. With our tables, it can also be useful to figure out what the total sums of each of these rows and columns are as well. And to figure out what the sums, or to add those sums, our function is basically to add margins. And so we haven't stored this table yet. We could. Or, again, we can kind of nest our functions. So I hit the up button. We have our code to create our table. I can add the add margins function. Add margins function. Make sure I close my parenthesis there at the end as well. And so, again, it's going to read from the inside out. It's going to make the table, but then it's going to add the margins. And now we see, if I run my code, I have a row at the bottom for the sum total, and also a column here for the sum total. So I can see that the sum total of, say, business intelligence and visualizations, there's 313 of those jobs, whereas data analysis, there's 1,457. Again, similarly, we can read down the column. Entry level, looks like there's 496 entry level, 281 executive level, 1,869 mid-level, and 6,709 senior level positions open across all these different data jobs. So clearly it seems like they're hiring more senior level positions in the data science fields, or at least that's what the job postings are. It would not be out of the realm of possibility for the people running their companies or HR to be overly optimistic, or even maybe slightly delusional about what the job market actually looks like. But again, this is nice because we can see that where are most of the jobs. And again, we can look at the sum total. So like I said, 1457 in data analysis, that's pretty good. Data engineering, 2,260. But again, if I compare that to the entry-level positions in data analysis, there's clearly more data analysis positions out there. Then data science and data research, again, 3,000 jobs. So that's definitely the biggest group there. And 164 entry-level jobs, again, compared to 2,270 senior-level positions. Again, looks like we got AI is also another big one. But again, that's how we can kind of read that table. And the add markers is pretty useful. Another useful thing we can do with our table is, beside adding margins, we can also look at the relative frequencies for each of these as well, or the proportions. And to do that, we just basically do the proportions function and then feed our table in. So instead of add margins, I replace it with the word proportions. And now when I do my function, all right, looks like it might make more sense to round this. But we can see that instead of the raw data value, so again, there were 7 entry-level positions in business intelligence, and that corresponds to 0.0007 of all the jobs out there. Because we're looking at so many jobs, again, when we looked at the sum, there's 9,355 total jobs that are in this data set, right? That's the total sum. We can also see that that's the number of observations here in my environment. That's going to make some of these proportions really, really small. And if we see any larger proportions, like, say, this data science and research one, 24% of the jobs are senior level jobs in data science. So that's a little tough there as well. Now, if we want, we could first filter our jobs data frame for just the specific categories we're interested in, and then create a table from kind of our filtered data frame. which it might make more sense to save that as kind of an intermediate data frame in our environment as well. And then run some of these proportions or these sum as well. So let's see. I would say that because these relative frequencies are all kind of ugly decimals, let us instead just do the one with the total sums. So I'm going to create that table, and again, I'm going to add my margins. So copy, and I'm going to put that. I'm going to copy that code into my Markdown file. I'm going to use that. All right. So based on the table, what should we focus on? Well, again, if I do this again, where are most of our entry-level jobs? I want to focus on entry-level jobs here instead of the executives or mid-level or seniors. So for the entry-level jobs, looks like data analysis has 140, data science has 164, and then I guess the next biggest, we have data engineering at 95, machine learning at 64. But as we can see, we can even just do the math in the console if we really want to. For data analysis, there's 140 out of the 1,457 jobs. So that is a relative frequency of almost 10% of our data analysis jobs are entry level, which, you know, that's pretty good. But if I do data science, 164 out of the 3,014, that's less than 5.5%. So, all right. So again, looking at these two, I think we will focus on entry level data analysis jobs. Now, certainly feel free to play around with this data set some more. Again, that's what we're going to focus on for the rest of this lab, but there's a lot more questions that we can ask and answer about this data set here. And, you know, definitely let's play around with that a little bit. Okay. Now, if I want to narrow down these jobs, so I want to create a new data frame now. I'm going to call it entry jobs analysis, so like entry level jobs in data analysis. And I want to include only the full-time, so I do want full-time jobs. I want entry-level jobs in data analysis, and I want them to be in the United States. And then I also want to know exactly how many jobs are going to fit that job description. So basically, I need to do a bunch of filtering here. And although we can combine some of our filters, I think in this case, I'm going to put each one of these filters for each one of these variables as its own function. So I'm going to do a bunch of piping, and that way if I do decide to change my mind later, I think it'll be much easier to read my code. My code will be more reproducible if I do it that way. So before I create a new object, let's just make sure my code works first, and then I can store it later. So we're going to start with our jobs data frame, and we're going to pipe that into, and like I said, we're gonna do a bunch of filtering. So the first one, full-time jobs. So I want to filter where, and now I need to make sure that I type my variables exactly the right way. So back, you know what, might just be easier here. I'm going to glimpse my jobs data frame again so that I have my variables right there to look at. So from my jobs data frame, pipe that into filter. All right, so let's see, we'll just kind of work down. So job category, that's my first one. So I want my job category to equal. Remember, we're doing our logical operators here. I only want job categories that equal our data analysis. And so again, I can copy and paste to make sure I spell everything exactly correctly and use the right case sensitivity. So that should filter just for the jobs and data analysis. So again, I can kind of run my code to check. And yeah, sure enough, I went from 9,355 observations to 1,457. Good, so that was my first filter. So again, we're kind of shrinking our data set here. And I'll pipe that into my next filter. And for this filter, I want to now filter for, we'll do the experience level. We'll do experience level. So experience level, again, that'll start to autocomplete too, hopefully. And we want the entry level. So again, if I look back at my table, it looks like that variable is the capital E entry level, but I'm just going to copy and paste. And again, let's check to see how much that shrinks down my data set. And let's see. We now have only 140 that fit that category. And again, that should be exactly correct because before we saw what's the overlap between data analysis and entry-level jobs. There's 140 of them out of the 9,355. So again, we are restricting ourselves to a much smaller little subset now. So that is working. So we have, what else do I want? Oh, full-time. I want it to be a full-time job and then also the United States. So let's add another filter. So filter, and now full-time. So let's scroll up again. That is going to be employment type. So again, I can copy and paste, or I can start typing and have it autocomplete. Equals, and we want full time. And I believe I saw up there that it was, again, a capital FULL-TIME. But again, we can double check, make sure I typed everything right. And yeah, now we're down to 133. So that's kind of interesting, right? That we had 140 jobs, 133 of them are full-time. So it looks like most of these jobs are going to be full-time jobs. There's not much part-time work there. And then, let's see, so pulling up that code. Oops, made a mistake there. Shift Enter. And my last filter is going to be, it needs to be in the United States. So again, I'll scroll up. And that is going to be we'll do the company location being in the United States. Again, like I said, we could definitely look and see if we could have foreign jobs that were fully remote. But yeah, I think we're going to stick with our company location being the United States. Yeah, let's do that. So that'll be my last filter. Company location equals the United States. All right, let's make sure that works. All right, so now we're down to 103. So there's only 103 jobs now that fit my description of, again, a data analysis that is an entry-level job with full-time work in the United States. Okay, so let's see. That works. Let's use that code. And again, I want to save this now as the entry underscore jobs underscore analysis. And so now I'm going to save that into my environment. Good. That's saved. And I do want to copy and paste that code. So again, inside my markdown file, that means that again, I'm going to run through this and I am going to, obviously this new data frame exists over here in my environment as data. Now I want to make sure that it's still going to exist over here as well. So now I want to include code that's going to store the number of observations as our job number. Because again, that's the second part. I want to determine how many jobs are going to fit this description. All right. Well, that's really just how many observations there are, which would be the number of rows in this data frame. So if I just do n row of my entry jobs analysis, it's going to get the 103. Now, why do I want to do it this way? And why do I want to store this as its own variable when I can just see from my R Studio setup, I can see from my code that the answer is 103. Why am I creating a new variable for this? Well, the really cool part here is going to be that if I do this, and so job underscore num, so again, I'm going to save the rows as its own thing. So now I have, again, values over here. The number of jobs is 103L. Remember that L means it's an integer. And again, since we're just counting numbers, it makes more sense to store it as an integer. It has to be a discrete value, right? Only the counting numbers work. And again, I'm going to copy and paste that code here. By creating a new variable for this answer, when I go down here to answer this question, how many jobs fit our new description, what's going to be really, really neat is that I can actually include the code to display the value of this variable for me. And what that is going to do is it's going to make my code much more reproducible. Because what's going to happen is that if I put the variable here instead of just the number 103, if I get a new data frame, as long as I still have, jobs, as long as I still, if I get an updated CSV file, right? Like let's say he scrapes the web again 6 months later to see what the new jobs are so we can see if there's any trends. I will be able to just use the updated CSV file and it will run through all my code and it will do all this work for me and it will update the new number of jobs in my markdown file as well. So how do I actually tell my markdown file to pull from variables? Well, the answer is going to be with the tick marks. So the tick marks are how we separate our code, right? These code chunks get these 3 tick marks to separate the code. So we want to use just one tick mark inside of our markdown file that we're actually typing and texting. We do one tick mark. And so the tick mark is the button that's right next to the 1 on your keyboard, right? So be careful. It's not the apostrophe, it's the tick mark. So the number of jobs is, and then we type the letter R because we're doing code in R. We press space. We can see it even put the other side of my tick mark there. So it should have changed colors. We should get kind of a darker gray. I'm not sure if that'll show up on your monitor here, but hopefully that shows up. And then we tell it what variable we want it to pull. So JOB underscore NUM. And so the number of jobs is this variable. Now, we've seen this actually before where we put the letter R and then we tell it to pull a variable. And we actually do that sometimes at the top. In our header up here, the date, we have that tick mark and then R. And then we have the system date so that it updates every time we knit our file. So let's actually knit this file together and see what happens. So I'm going to knit this. I believe I have it set as HTML. Good. And so when we go through, again, we have our answers, how it looks, and see down here, this is the big one. How many jobs fit our new job description? The number of jobs is 103. It's pulling that variable and typing it here. If we were to update that variable through code or from somewhere else, it will absolutely update in our markdown file as well, which is really cool. Again, that's that reproducible part. I'm going to be able to basically start with a brand new set of data or an updated data set plug it into all this code that I'm doing in my Markdown file, and boom, we will be all set. Now, another cool thing about doing these Markdown files, if we notice up here, we installed the packages. Like I said, we do the 3 tick marks. That gives us our code block. Then we type we always want to describe our code block. So again, we use kind of our braces, the squiggly brackets, the letter R. And then again, these are our preliminaries. Again, you can use whatever word you want here. And then on each of these I have include. And the include is our argument whether or not I'm going to include that code in what I'm doing. So include false. That means that, again, when I knit this together, even though I installed the packages, I don't have that, there's no code here for installing my packages. Now, let's see, here when we did our table, we created our table, and again, include false, it didn't show me my table. If I change that value to true, and now I knit my code together, again, still not showing there, but now I have my table, right? The result of my code is being displayed in my Markdown file. And I can start making my Markdown files look more and more professional. And so that's what I want you to do here. I want you to change that code so that include equals true, meaning we're going to include that code in our Markdown file and the results of that code, so that we can see this table that we created. And again, that'll be a big part of doing data science, is explaining your results, right? We do all this analysis, and then you need to be able to explain that. You need to communicate those results to someone else. Well, yeah, sometimes we can just include our code here. Now, be careful. If I had told my code to store this as a variable, right, or to store this table, it would not display here as well. Right? Whenever we tell the code to store something, that's what it does. It puts it in the environment for us. Now, that actually brings me to another interesting thing about these tables. When we look at our data frames, we have tidy data. That means that every row is its own individual observation, and then we fill in each of those columns with a value for that particular variable. That's tidy data. Every observation is a row, every variable is a column, and then, that's tidy data. This table, this is not tidy data, because, again, what this table is doing is it's looking at 2 different variables at once. It's not that there is one observation for business intelligence and that the variable for entry level is 7. Again, what this is doing, this table is summarizing our data for us, so this table is not actually data. And I'm going to show you that R actually knows that this is not going to be tidy data, or it's not going to count as it's not actually even going to count as data. So I'm going to copy and paste this code, so I'm going to bring this back over here. Let's see. All right. I'm going to copy and paste it. If I did store this table as an object in my environment, so let's just call this T job. I don't care. If I store this in my environment, T job is being stored as a table of numerical values now. All right. But it is not a data frame, right? See, there's a difference there in the way that R stores these things. And if I didn't have the add margins function, notice that it actually switches it. It's not even data anymore. If we don't have the margins or the sums at the end, it literally considers this entire table of values just to be a value. There's no function for adding margins. So again, it's just kind of an interesting way that R stores some of these data types and just things to be aware of. But again, we're not doing anything with this table. We don't need to store it. So I'm going to remove this using the RM function. So remove tjob, and it's gone. Okay. So, like I said, Make sure when we go back to this contingency table, we're going to change this include to true so we can see it in our markdown file that we print out. And again, we should have our code to create our entry job analysis, entry jobs and analysis, our code to figure out how many there are, and again, our reproducible code here. Okay, next up, I want to explore the salaries in our entry jobs analysis. So what are the expected salaries for this specific set of jobs? So we can summarize the min, the max, the mean, the standard deviation, and then let's try to create a histogram of the data as well. So again, a couple ways we can try to do this. So let's see. We could do each of these individually. So we could, like I said, if I want to find the min, min is our function for the minimum. What's the minimum of my entry jobs in analysis? And I want to look at just the row for, and again, we're going to use the salary in US. I guess it doesn't matter. I guess we can just use salary since it should be all US jobs anyway. We can use salary. And again, it'll tell me the minimum salary is $20,000, which that feels ridiculous for a full-time job in data science. But like I said, you know, some people are delusional. But back to our data analysis, even though we could do that individually, remember, if I want to summarize this in our markdown file, though, like I said, I could do this and I could absolutely write out my code where I store this as a value in my code chunk, and then I write some sentences down here below about what that is actually going to be, right? It'd be like the minimum is, and then I can use that variable. So if you want to do that, you can absolutely do that. Use that new technique, or we could use what we've been doing, and we could summarize all of these values in one summary table, right? We can use the summarize function and then pipe in our new data frame, summarize, and then pick what are the values we want to see in our summary. So using the summarize function first, again, we start with our entry jobs analysis, right? That's the data frame we're looking at now. We will pipe that into our summarize function. So summarize, I feel like I got to make that a Z for some reason. All right. And we want the minimum, the maximum, the mean, and the standard deviation. So the minimum equals, and we use the min function. And again, because we're already piping the data frame entry jobs analysis in, we know that's our data frame. Now we can just title our columns, our variables. So salary, it is under, it's lowercase. Okay, so salary, the minimum for our salary, the average equals the mean of our salary again. The maximum equals the max of our salary. And then the standard deviation. So then the standard deviation equals, and the standard deviation function is ST. So the standard deviation of, again, salary. So if I run that code, unexpected symbol. What is my unexpected symbol? Entry jobs analysis, piped it, summarize, equals, well, let's get rid of, let's do one at a time. Can I find the minimum of the salary? Okay, so that part worked. Okay, so worked if we did minimum. Let's see, comma, average equals the mean of salary. Let's see if that works. Okay, so we got the minimum, we got the average, the maximum equals the max of salary. Let's see if that works. That works. And then comma, standard deviation equals SD of salary. Okay, so the standard deviation doesn't want to work. Why not? Hold on. Well, let's look at the standard deviation function in the help feature. SD, and the argument is a numerical vector. That should be just fine. Unexpected symbol. Standard deviation. Hold on, what if I call it the standard deviation? That worked. Oh, maybe I could not have my title have a space in it. Okay, so that works. So we see that the minimum salary posted was $20,000. The average salary posted was about $77,000. The maximum, there was a salary up there at $163,800, and then a standard deviation of $25,848. So definitely have quite a bit of variation here. So I'm going to, again, preserve this code, copy and paste that code. And up here, so I'm going to include summarize the min, max, mean, and standard deviation. So I'll copy that code here. This is where I'm exploring it. Again, I have include is equal to true, which means if I knit this together, it should definitely knit my my table here that I created. And now create a histogram of that data. So entry, jobs analysis, we will pipe that into our ggplot, our aesthetics, our x variable. The only variable we really care about is going to be the salary. So that's all I'm going to worry about for now. And we will add the layer where we're going to add a geom, in this case histogram. And let's just see what it looks like. Ooh, okay, that is all over the place. So again, the default is it always starts with 30 bins. We can do better. So again, I like to start with bin width instead of the number of bins. So again, with this kind of variation from 20,000 up to 163,000, let's start with a bin width of 10,000. See what that looks like. All right, I think that's reasonable. Again, I think if we make our bins any wider, we might start to get a little uglier. If we make them any more narrow, that could be a problem too. Okay, so I think that pretty much works for the bin width. So we will copy and paste that and put that in my code as well. So copy, paste. Now, I don't like the way that this looks. What you should do as well is add some other things here. At the very least, let's add some labels. And then we can also play around with maybe the colors, try to make it look nice. I want to see you customize this in some way that you think will make it look better. And again, whether it's colors or labels, or borders or backgrounds, think about some ways we could customize this and change the way it looks. I'm expecting at least one level of customization when you submit your knitted PDF. But I'm going to knit this now as HTML just so we can kind of see what we're looking at. So again, we have our project, jobs and data, our introduction. Again, like I said, we're now including this table, which makes it look nice. We explored our jobs, now down to the salary. So again, we included our text command, right? What is the code I use to get my answer, where I summarize the min, max, mean, and standard deviation. I have my output so that I can see those. And again, I have my output now of my histogram. We can also customize this in a bunch of other ways. We can change the sizes of things. We can include just the output of our code instead of the input as well. But again, when you knit your PDF, I want to see the input code as well. So I want to see exactly how you're going to customize that histogram. Okay, so we only have, hold on, let's get back to blank console here. Now, we only have about 103 jobs to choose from with a lot of variation. And hopefully we can see here as well that it definitely seems like this data is also skewed right? My mean over here is about 77,000, and we definitely have a much longer tail here on the right-hand side. So you have some skewed right data. A lot of times, if I want to make any sort of conclusion, like with a confidence interval type of thing, if I want a confidence interval and to include both sides, typically we want a distribution that is more normal. But again, this is a population of only 103 different values. If I want to get a normal distribution, I'm going to have to actually create a sampling distribution from this data set. And this is kind of a really, really beautiful and genius way of doing statistics that even if I have a data set that's not big enough or it's a little skewed, if I create enough samples out of my data set, I can actually start to turn this into a normal shaped sampling distribution. So this does get a little kind of layers on layers here. So it's very, very important that we define everything in our code first. So first, how many samples do I want to take and what's going to be the size of each of these samples? So with this sampling distribution, I can get thousands and thousands of samples and look at them all at the same time. So I'm going to say, so I'm going to have to do this in two different places. I'll do it in my console first. So n equals, and again, we want at least 1,000. This is going to be quick. Maybe we'll take 2,000 samples. So let's do n equals 2,000. And again, I'm going to copy and paste, or you could just write n equals 2,000 up here. That's not the number of samples. And how big is each sample going to be? So that means from my 103 choices in my population, how many am I choosing for each individual sample? How many am I randomly picking for each sample? Now, the most important theorem probably in almost all of statistics that really lets us do statistical modeling like this, or to do things like Monte Carlo simulations, is central limit theorem. And the central limit theorem basically states that as long as we take samples that we take enough samples of samples that are big enough, we should be able to get a normalish shaped sampling distribution. So we're going to say k is the size of each of our samples because we can't use the variable n more than once. And so let's say k equals, typically 30 is a decent sized sample. Again, especially since we only have 103 in our first one to begin with. Let's try k equals 30 and see what that looks like. So k equals 30. Then we need to make sure that this is reproducible and that everyone will get the same results that we do, which means we will also now have to set our random seed. And so we'll do set, well here, we'll take a look at the set.seed function. I spelled it right. Let's spell it right. The set seed function. And so again, we see the random number generation in R. The random seed is an integer vector. and that contains basically our random state that we're going to use. And set seed is our recommended way to set seeds in the R programming language. So again, there's lots of different ways we can kind of do that, and we can read through more of that. But basically, the way the set seed function works is we're going to use the function, and then we literally type in what value we want for our seed. So set.seed, and we can just pick any number. I don't know. Let's do 314, right? Who doesn't love pi? So now I've set my seed. And again, I want to make that part of my data here as well. So I'm going to include that up here. And so that sets my random seed. Now, the next thing we want to do is, again, I'm going to create a sampling distribution where I'm taking 2,000 samples. And so, again, what the code's going to do is it's going to take my data frame that has 103 observations. It's going to pull 30 of those. And then I want it to find the average salary of those 30 that it pulls. I want to save that average value somewhere. And then I want to go back, pull another random 30 jobs out of that set, find the average of that, and store that as well. So typically when we do things like that, one of the things that we want to do is actually create kind of an empty vector to store each of those sample means as we go along. So to create a new vector to store these sample means, well, I'm going to use the rep function. And so again, we can, no, I just want to look at rep, just the rep function. And the rep function means we replicate elements of vectors and lists. And so we see that with the rep function, there's really two arguments. What is the data that we're using? What do I want to replicate? And then how many times am I going to replicate it? So we want an empty one. So again, I'm going to call this sample underscore means, because that's what we're basically saving is our sample means. And so we're going to create an integer. And so we're going to use rep. What data do I want? Well, I want it to be empty. I want it to be empty for now. So I'm just going to say NA, basically just I want a bunch of undefined objects. And then how many times do I want it to repeat? Well, if I'm taking a sampling distribution with 2,000 samples, it needs to be 2,000 long. So sample means rep 2,000 long. And so again, we see all of a sudden here in my values, I now have an object called sample means. It says it's stored as a logical, but it's indexed from 1 to 2,000, meaning that, again, there's 2,000 entries, and every entry is NA. Now, I know it says logical here, which means it's storing true and false values. That's just because it's kind of by default. I first created it. Once I actually start running my code, obviously I'm looking at sample means, so I should be storing doubles. It will automatically, as soon as it starts to overwrite, it'll change that to a double for us. R will be smart enough to know how to fix that. But again, that's how we can create a new kind of blank empty vector for ourselves to store it in. So we'll call that our sample means. All right. And now, if I want to sample these 2,000 times, I want to create a for loop that's going to repeat those 2,000 times. And each time we'll choose a sample of our k observations. Now again, I could type all of this in. Well, yeah, let's actually go through about how we can make our code more reproducible. So, like I said, it starts with a for loop. So a for loop, and then again, we start with our parentheses. And the first thing we have to define in our for loop is, well, how long is this going to be going on for? So we use another counting variable, I, right? I is going to be the number of times we go through each observation, or each time we loop through our code. So for I being the counting variable for this looping code, in, and I want to start at 1 and I want to go up to n. Now, like I said, I could type 2,000 and it would do this 2,000 times, But the reproducible part of our code is that, again, if we had set these variables earlier on in our code, if I want to update, or if I want to run my sample, I don't want to see, well, what happens if I change it to 10,000 sample means? Or what if I only do 10 sample means? Or if I want to change that, all I have to do is change this value of n up here, and it will automatically change the rest of my code for me, making life much, much, much easier. Okay, so we're telling our for loop how many times to run. So for every integer value between 1 and n, which is 2000 in this case, what do we want my code to do? So now we have the brace, or that squiggly bracket. Remember, that is kind of like the shift square bracket. And again, R is going to automatically give us both sides. To make our code more readable, we want to go down to the next line, so shift enter. And we can see that that really gives us our space for what we actually want to do. And so each time we run through this code, I want to take that sample means vector that we created. I want to index it, and I want the ith term. So again, we're start at 1, right? And each time I run through the loop, each time that for loop runs, it starts at 1, it gets to the end, I turns to 2. It gets to the end, I turns to 3, it gets to the end, it turns to 4, all the way through till it gets to 2000. So again, this will index all of those 1 to 2000 entries we have in that vector. And what I want to happen is I want that indexed to be equal to the average, or the mean, right? That's my function. I want to average all of the salaries in my sample. So I'm going to average. Now I need to define how I'm going to take my sample. So that's the sampling function. And what am I sampling from? So again, we can see that we have our different choices here. The first is going to be X. So X is our data. So what am I actually sampling from? What data am I taking? And so X equals, my data set is going to be my, entry jobs and analysis, right? There's my data frame that's auto-completing. Then the $sign, I want that specific row. I only want the salary. That's what I'm concerned about. So tab. So that is my data I'm pulling from, X equals. We can see that the next argument is going to be the size. So size, how big is my sample going to be? Well, okay, we defined how big our sample is going to be. That's how many we're pulling. So again, at this time we're choosing 30, and hopefully it'll look all right. And again, the reproducible code, if it doesn't, if I want to choose 50 or 10 or whatever, I can just go back to that code earlier on and say, you know what? Let's try a different sample size for this. So size equals K. And then the replace. So we can see that by default, the replace is false. But I think, again, because we're only dealing with 103 pieces of data, we're going to allow replacement for this. So I'm going to set replace equal to true. And that code should work. And again, what's going to happen, it's going to run through my code. It's going to go 2,000 times. And each time it runs through, it's going to replace that entry in my sample means over here, right? We can see it in my environment. It's going to overwrite one at a time with the average of those 30 that it picked for each sample. So let's run my code. And nice. All right, let's see immediately, right? My sample means over here in my environment, it switched to now its numerical values for all 1 through 2,000 entries. And my first average was 76,000. My second average was 86,000, then 83, 72, 74. Well, again, rounding. And so, again, I have this entire base set of values. There's my sample means. I created my samples. So let's see. Good. I have my thing. I'm going to actually make my samples. So I'm going to copy and paste that code with my for loop. So under R making sample, I'm going to include my code there. Right? I'm going to copy and paste it. I don't need to necessarily include it. I'm going to leave that as false. I made this one as true, so I know what it's called. But you play around with that. Do you think it's going to make more sense to make these true and include them, or make them false? So make that part of your conscious decision as you knit this together as a PDF at the end. Yeah, hopefully that will kind of help us. All right, now explore 2. Now for my sampling distribution. So if I'm looking at 30 at a time, what would I expect for the average? So one of the things that's going to happen now with our sampling distributions, again, because I'm looking at 30 at a time, my mean, my average should still be the same. The average of a sampling distribution should still be the same average as your population. But what's going to happen now is those extreme values of like 20,000, or again, we had those outliers of 163,000 or so. Each time I have those extreme values, they should be averaged out by all of the other values as well. And so I should get what is hopefully a cleaner distribution and a better idea of what to actually expect. So we want to summarize the min, max, mean, and standard deviation of all of these. Let's see. All right, so we don't have any data necessarily to pipe in here. So let's just test to see if our summarize function can work with a vector. Because again, a lot of this is just exploring. We're not going to figure out what R can and can't do unless we explore and try new things, and it might not always work, but it's worth at least trying. So the summarize function, let's see if we can find the minimum. So the minimum, min e mum, equals the min of my sample means vector. Let's see if that works. No, shoot. We cannot use the summarize function applied to the class of a vector. If I use the summarize, it's got to be a data frame into a data frame. Now, what we can do is we can actually say, well, all right, I know that this sample means is a vector, but just for this scenario, let's treat it like a data frame so that I can use my actual function. And so if I use the as.dataframe function, which is like a base R function, so as data frame, and I type in my sample means, it's going to take that vector, turn it into a data frame just for this one purpose so that I can use it in my different functions. So now let's try to pipe that into my summarize function. So summarize equals min e mum equals the min of, let's see, I guess this data is the only data. I wonder if I have to define that. We'll play around and check. Missing argument. Okay. So let's see, from sample means. And there we go. So now the summarize function is treating this vector as a data frame so that we can use the summarize function. And so I see the minimum now is 62,506. So again, if I get groups of 30, right? I'm sampling and I'm choosing 30 of those salaries out of the 103, and I average those 30 together. Now the minimum number I got was 62,000, which is a lot different than the 2,000, because again, anytime I pull to 2,000, it's going to be averaged out by everything else. So let's see if we can do the rest. So minimum, the average I can spell, equals the mean of the sample means, the maximum equals the max of the sample means, and the std underscore dev equals the sd of the sample means. Let's see if that works. Boom, there we go. All right, so we can see the average still 77,000. Now again, that's I think maybe slightly different than the other one, but again, we're almost right there. The maximum also, we shrunk ourselves down. Instead of having a maximum of 160,000, we're seeing a maximum of 93,000. So again, that gives us a much more reasonable expectation. We're basically kind of eliminating some of our outliers. And our standard deviation, which was over 20,000, I forget what the exact value was now, drops down to 4,600. So again, we can kind of shrink down our distribution and gives us a much more reasonable way of using the exact data, but giving us a smaller range of values for this sampling distribution. So, okay. All right. I'm going to copy and paste that whole code. So, copy and paste. This one I definitely want to include as true. Again, we have making our sample. We have our sample mean vector. So again, all those variables should still be there. And then we want to create a histogram. So going back, we want to basically do the same exact thing. As data.frame sample means, now I can plug that into ggplot. And I do want to mention there are graphing functions that can absolutely take vectors as their inputs, as their arguments. But again, we're sticking with the tidyverse, and in the tidyverse, we want all of our data as data frames. And so, well, sometimes we have to kind of coerce it that way, but that's fine. So ggplot, our aesthetics, x equals sample means. We're going to add our layer for geom underscore histogram. We run the code. Oh, and look at that. I actually get what looks to be much closer to a normal distribution for my data and gives me a much more reasonable expectation for what to expect. Okay, so that is about it. I want you to update the bin width for this code. We want to update the bin width. I also want you to add your labels. Again, in this case, it is important because we have sample means, so I want you to really label what is the sample mean telling us. There should be a title to this as well. Make sure we copy and paste that into our markdown file as well. So again, make that look nicer. Make sure it ends up in the markdown file, and then answer the last question. When we compare this sampling distribution to our original population distribution, how do those two things compare to each other? And you have to answer that part in words. All right. If you have any questions, feel free to email me. Otherwise, I hope this was a decent little code along, and we used a bunch of cool new things like the unique function and sampling. And yeah, as always, take care of yourself, guys.